Alright, in the last video we talked about how we could graph a linear equation or simply a linear relationship such as y equals to 2x plus 1 by simply setting up a table of values by selecting integer values of x and then just calculating the value of y that corresponds to each one. So we know that for any value of x that we choose, we can find a value of y and then we can create a point on the Cartesian plane based on those coordinates x and y. Let me just redraw that y that I drew here. So we can create a point, and basically by joining the dots we can see that if all those points satisfy this equation, then they should all lie on the same line, and we normally refer to those points as collinear. And collinear really just means that they are on top of the same straight line. That's pretty much what they mean. Now what I want to do in this video is I want to show you how it is possible to actually, instead of having to draw a little table of x and y values, we can draw a straight line equation very directly by simply noticing where it crosses the y and the x axis. So for example, where the line crosses the y axis is called the y-intercept, and wherever it crosses the x-axis, it is called the x-intercept. And the reason this works is because whenever we know at least 2 points that lie on the same line, we already know what the line is going to look like because we know what it's going to go through. I mean, we could draw more points than that, but obviously that wouldn't really give us any extra information other than the fact that those points also lie on that line. And you can prove that yourself by just having a random Cartesian plane on your book. So just draw some Cartesian plane and select 2 points. Select 2 points here, and then join the 2 dots by using a straight line. You'll notice that there's only one way in which you can do that. There's no way that you could pass through this point like this and then cross that one, because that would not be a straight line, of course. You could have 3 points, but they may not necessarily be collinear. So you could have something like this or that, but then again, they're not necessarily collinear. But 2 points will always give you the equation of a specific line. So I guess that's a really important thing that we need to know. So if we were to look at some random equation, like for example y equals to 1 over 2x plus 1, we could do the same thing we did in the last video and just draw a table of values for x and y, and then just plot those points and join the dots. But obviously that takes quite long, so there's a much easier way in which we can do that. So first of all, we can find the y-intercept. So the y-intercept is that point at which the line crosses the y-axis. So if we look very carefully here, the y-axis is always at the point where x equals to 0. So basically, if we make x equals to 0 and put that value into the equation, we can find that point on the y-axis where the line is going to cross it. So we could say y is going to be equal to, well, half times 0 is 0, so that's just going to be 1. So we could easily say in this case that the y-intercept of this equation here is going to be the point 0, 1. And similarly, if we wanted to find the x-intercept, then all we would need to actually know about that line is the fact that, well, if we make y equals to 0, because that's how the x-axis is defined on the Cartesian plane, that's the axis at which y has a value of 0, then we can actually rearrange the equation and we can find the value of x. So we can write, okay, so if y is equal to 0, we can write the equation half x plus 1. And then one thing we could do is we could subtract 1 from both sides. So that leaves us with minus 1 equals to half of x. And we can now multiply both sides by 2. So that means that x is going to be equal to minus 2. So at this point, we can say that the x-intercept is going to be located at the point minus 2 and 0. So now that we know those 2 points, all we need to do really is just draw a set of axes. So we draw our x and y axis here. And now we know what the 2 points are going to be. So let me just select a different color here. So the y-intercept is going to be at the point 0, 1. So that's going to be, let's make it here. That's the first point. And I should actually label this properly, so let me just do it in yellow. So we have 1 here. Let's do 2, 3, 0. And then we need -1, -2, then 1 and 2. Okay, so let's do, so we know that there's a point here, that's the y-intercept, and now let's do the x-intercept. I'm gonna do it in dark blue. So the x-intercept is located at the point -2, 0. So now what we can do with this is we can draw a line that is actually going through both of those points, and then that's it. We have drawn the line that corresponds to the equation y equals to half of x plus 1. So this is really, really interesting, because now we can actually do things without having to draw a table of values and just having to calculate x and y for each of those points. We can just find from the equation itself, by plugging in values x equals 0 and y equals 0, we can already infer what that's going to be. And I think this is a really, really great thing to do, because I mean, it just shows you the many applications of algebra. We're just rearranging equations here, and by doing that we can actually find the values that are going to give us that straight line. Now I could give you another example of that. Let's say we have y equals to, let's say, 1/3 of x minus 4. Okay, so we're going to apply the same technique again. We're going to say, okay, to find the y-intercept, we're going to set x equals to 0, and then we're going to have y equals to -4. Therefore, the y-intercept is going to occur at the point 0 and -4. Then, to find the x-intercept, we set y equals to 0, and then that means that we're going to rearrange the equation. So we're going to have 1/3 of x minus 4 equals to 0. And then we can have 1/3 of x equals to 4. And that means that if we multiply both sides by 3, x is going to be equals to 12. So that means that the x-intercept is going to occur at the point 12 and 0. So what can we actually tell from that? Well, if we were to plot it, I'm not going to plot it in the same graph, because you can see that we need a lot more units on our grids. So I'm just going to draw a set of axes that is a little bit better to scale. So that's going to be my x-axis, y-axis. Let's say this is 0. Let's say this is -4. And then we're going to have, so I'm just going to plot the points here. That's going to be, let's say, 12 over here. So now that we have those 2 points, let me just mark it here. All we need to do is we draw a line that joins both of them. So this one is going to be a little bit tricky because I'm doing it on a tablet, so obviously I don't have a ruler to help me with. But hopefully, by doing it very, very slowly, you can see what kind of shape this line is going to have. So in general, you can usually find the y-intercept and the x-intercept of a line just from the equation itself. And that way you can actually know what kind of shape it's going to have. So in this case, if we were to say, okay, so let's say we wanted to find the value of the line at the point 3, so somewhere around here, well, we know that we can just go down here, and the value of y that corresponds to that point will be somewhere here. So I'm guessing that would be maybe between -2 and -3, or maybe a little bit larger. I mean, it's not drawn to scale, of course, so it's hard to tell from here. But we can just plug in the values in the equation here and then just find that out. So this is a really, really good trick to find the equations of the lines very quickly and know how they look like on the Cartesian plane. And in the next video, we're going to be doing a lot more examples on this so that you can apply this knowledge to some exercises.